In this lecture, we will discuss right arm, right leg lead reversal and how to identify it on the EKG. Making sure that the EKG leads are connected to the correct electrode position is important for getting accurate rhythm strips in 12-lead EKGs. If the leads are reversed, we call this lead reversal, and it can often produce EKG abnormalities. It's important to be aware of these accidental misplacements of the limb lead electrodes because they can mimic various pathology, including chamber enlargement, ectopic atrial rhythms, or even myocardial ischemia and infarction. Now, when the limb electrodes, that is the left arm, the right arm, and the left leg, are exchanged without disturbing the neutral electrode, which is the right leg, then Einthoven's triangle is flipped 180 degrees or rotated, resulting in leads that switch positions, become inverted, or remain unchanged, depending on their initial position and the vector. Remember, the goal here is to be able to see why these EKG changes occur and then be able to reason them out on your own instead of memorizing anything. We'll also mention a few things that help to identify this type of lead reversal. So here we're going to look at what happens when the right arm and the right leg electrodes are reversed. In this case, Einthoven's triangle collapses to a very thin slice with the left arm electrode being at the apex. Okay, so again, here's our right arm. Okay, and we're also looking at our right arm and then our right leg or neutral electrode, and we're going to see what happens when these are switching places. Okay, and what we have going on here is that you can see that the right leg comes up in this position where the right arm was. Okay, and we're bringing the right arm down here in that neutral position where the right leg electrode was. Okay, we're saying that the left arm comes to our apex of our triangle here. So the left arm becomes the apex, which is this part here. Okay, so hopefully that makes sense so far. Now the right arm and the left leg electrodes are now recording nearly identical voltages, making the difference between them negligible. That is, lead 2 becomes a flat line with zero potential. Okay, so if you look at lead 2, which is from our right arm to our left leg. Okay, so let's see that. Here's our right arm and our left leg, and you can see it's pretty much a flat line. Okay, so lead 2 pretty much becomes 0. So if you look here, this is our normal EKG with lead 2 looking at our limb leads, and this is our right arm, right leg reversal in our limb leads, and notice that we have lead 2 has zero potential. Okay, so you pretty much get this flat line here in lead 2, so that's an important thing to be aware of. Okay, this flat line showing zero potential of lead 2 can help distinguish it from other types of limb lead reversals. Additionally, now AVR and AVF are essentially mathematically identical, such that they appear identical on the EKG. Okay, so we're looking now at AVR and AVF. Okay, so remember AVR was here, now it's coming in this position down here, so here's AVR and AVF pretty much at the same line, and they'll look pretty much the same. Okay, here's AVR, AVL. Okay, now AVR and AVL are pretty much going to be identical. Okay, and because of that, they will pretty much look the same. Excuse me, that's not AVR and AVL, it's AVR and AVF. Okay, so AVR and AVF, which are the ones down here that we pointed out, so this is AVR and AVF, they'll pretty much become identical because they're along that same line. Okay, so sorry about that. Here's AVR and here's AVF, and you can see them looking pretty much identical in that case. Okay, so AVR and AVF looking the same. Okay, now lead 3 is unchanged, and this is because the left arm and the left leg electrodes are not affected. However, AVL will run within this thin slice and face approximately opposite to lead 3. Therefore, AVL is nearly an inverted lead 3. Okay, so if you look here, we have lead 3 going from our left arm to our left leg. So here's lead 3. Again, not really disturbed. Our left arm and left leg, here's lead 3, really not changing. Okay, so lead 3, which is here, becomes unchanged in that case. Okay, so no changes to lead 3. But we said that AVL will pretty much become in an inverted lead 3. Okay, so here is lead AVL. Okay, and what we're going to see is that it becomes inverted lead 3. So why is that the case? Well, it's because that lead 3 normally goes from in this direction, okay? And notice that AVL is going in this direction towards it. And now again, lead 3 still going in the same direction. And notice AVL still up here, and it will pretty much going in the opposite direction. So we can see that AVL pretty much becomes a inverted lead 3. So here's lead 3, okay? And here's AVL. We're saying that AVL and lead 1, okay, are pretty much identical. And notice that here is an inverted lead 3. Okay, so hopefully that makes sense. So we said that lead 1 will now essentially be going in the opposite direction to lead 3, and therefore lead 1 will be an inversion of lead 3. Okay, so if you look here, we have lead 1 that goes from our right arm to our left arm. So here's lead 1 going from the right arm to the left arm. Okay, and now as we switch those right arm and the right leg, here's lead 1 going from the right arm to the left arm. Okay, notice it's going in the opposite direction as lead 3. Lead 3 was going in this direction. Lead 1 is going in the opposite direction, just like AVL. Okay, and that's why we say that lead 1 and AVL are essentially identical. Okay, because they're both going in the opposite direction of lead 3. All right, so hopefully that one makes sense. Now, one thing to be aware of is that the precordial voltages may also be distorted, and that's because we're moving the right leg or neutral electrode. Okay, so whenever you move that right leg or neutral electrode, you may distort also the precordial voltages, which are leads V1 through V6 are our precordial leads. So let's briefly review what we discussed before we end. So now we're looking at right arm and right leg reversal. What we said here is that Einthoven's triangle collapses with the left arm coming to our apex. As we saw, lead 3 is unchanged. Lead 1 and AVL are inverted of lead 3. Okay, so again, they're identical. We saw here's lead 1 and lead AVL are pretty much the same, but they're inversions of lead 3. Okay, that's why we said 1 and AVL are the same. Lead AVR and AVF are also identical. Okay, so here's lead AVR and here's lead AVF. You can see them being identical. And then the one that I wanted you to keep in mind was this flat line, zero potential of lead 2. Okay, so remember, lead 2 comes down here. Okay, and you can see that it becomes a zero potential, and that's what we see going on here. So, okay, so here's lead 2, our zero potential that can help point you towards this right arm, right leg reversal. Well, that's the end of this lecture. We discussed right arm, right leg lead reversal and how to identify it on the EKG. I hope you learned something.